Hey everyone, welcome back to the channel. Today we're tackling a fundamental concept in the world of networking, the OSI model. This model is like a blueprint that helps us understand how data travels across networks, whether it's your home Wi-Fi or the entire internet. It breaks down the entire process into 7 distinct layers, each with its own specific function. So let's dive in and demystify the OSI model layer by layer. Alright, let's start at the ground floor, the foundation of our networking house, the physical layer. This layer is all about the tangible stuff, the hardware that makes up a network. We're talking cables, those Ethernet cables connecting your computer to the router fiber optic lines that bring you high-speed internet, and even the wireless signals beaming from your Wi-Fi router. It defines the electrical and physical specifications for how data is transmitted. So whether you're streaming a 4K video on Netflix or sending a simple text message, those bits are being converted into electrical pulses or light signals at the physical layer. Now that we've established a physical connection, we need a way to manage the flow of data on a local network. That's where the data link layer comes in, our traffic controller. This layer ensures that data is transmitted reliably and without errors between devices on the same network. It uses MAC addresses, unique identifiers assigned to each network interface card, to identify devices on the network. So, when you're downloading a file from a server on your local network, the data link layer is making sure that each data packet arrives in the correct order and without any errors. Okay, so we can send data reliably within our local network, but what about connecting to devices on other networks like those across the internet? That's where the network layer steps in, acting as your data's personal GPS. This layer is all about routing, determining the best path for data to travel from its source to its destination, even if it involves hopping across multiple networks. The network layer's most famous resident is the router, a device that connects different networks and makes routing decisions based on IP addresses. So when you're browsing a website hosted on a server thousands of miles away, the network layer is working behind the scenes, ensuring that your requests and the website's data find their way to each other across the vast expanse of the internet. We've successfully routed our data across networks, but how do we guarantee that it arrives at the destination reliably and in the correct order, especially when dealing with the unpredictable nature of the internet? Enter the transport layer, the guarantor of reliable data delivery. This layer is responsible for establishing a connection between the source and destination devices, and ensuring that data is transmitted accurately, even if it encounters network congestion or errors along the way. The transport layer has 2 main protocols it uses to accomplish this: TCP and UDP. TCP, or Transmission Control Protocol, is like a meticulous delivery service. It numbers and tracks each data packet, checks for errors, and requests retransmission if necessary. UDP, or User Datagram Protocol, is like sending a postcard. It's faster and more efficient but doesn't offer the same guarantees as TCP. So, the next time you're uploading a large file or having a video call, remember the transport layer is working hard to make sure your data arrives intact and in the right order. Now that we have reliable data transfer, let's talk about managing those conversations between applications. This is where the session layer comes in, our conversation coordinator. The session layer is responsible for setting up the call, maintaining the connection, and gracefully ending the call when you're finished. It synchronizes the dialogue between applications, ensuring that they're both on the same page. This layer manages checkpoints during data transfer, so if the connection is interrupted, the session can resume from the last checkpoint instead of starting from scratch. The session layer also handles authentication and authorization, making sure that the right users have access to the right resources. We're almost there. Now that we have a session established, we need to make sure that the data being exchanged is in a format that both applications can understand. This is where the presentation layer struts its stuff. It's our data translator and format specialist. The presentation layer acts as that translator, ensuring that data is presented in a way that the receiving application can comprehend. This layer handles data formatting, conversion, and encryption. For example, when you're sending an image file, the presentation layer might convert it to a compressed format like JPEG to reduce its size for faster transmission. The presentation layer also plays a role in data security, encrypting data before it's transmitted to protect sensitive information. And finally, we've reached the top of our OSI model skyscraper, the application layer. This is where you, the user, interact with the network and applications. It's the layer you experience directly, whether you realize it or not. This layer includes applications like web browsers, email clients, messaging apps, and countless others. When you open a website, send an email, stream a video, or download a file, you're interacting with the application layer. So, the next time you're browsing the web, checking your email, or chatting with friends online, remember that you're experiencing the power and convenience of the application layer. So let's recap. The OSI model is broken down into 7 layers. Physical, the hardware that sends data. Data link ensures data is error-free on a local network. Network handles routing and IP addresses. Transport makes sure data gets to the right place reliably. Session manages communication sessions. Presentation formats, compresses, and encrypts data. Application, where the user interacts with the network. Understanding the OSI model is key to understanding how networks work and troubleshooting problems. Thanks for watching. Hey, if you enjoyed this video and want to see more content like this, make sure to hit that like button, and don't forget to subscribe and ring the bell so you won't miss any of our future videos.